Hello students, this is the last problem in OS 1, problem number 4. I'm not going to work all of the solution to this one, but I'm just going to give you some hints and some things to think about. Again, please do not watch these solutions until you've already tried them out yourself. You won't get very much out of just watching me talk about it unless you've tried it yourself. But if you've tried number 4 and you're stuck, here are some hints. All right, number 1, check out the carbon skeleton. Is different, right? There's 4 carbons here and 4 carbons here, so we're supposed to convert one to the other. It says all of your carbons here should come from here, which means we need to tear this apart and stick it back together. Tearing this apart means what reaction? What is the only reaction we learn that will tear apart carbon-carbon bonds completely? That's right, alkene oxidation. So if we know we're going to use alkene oxidation, the hot acid flavor, we have to somehow convert that into an alkene. Here's your first hint. Here's the alkene that we're going to need, right? So we're going to do this. We're going to do hot alkene oxidation, which means, right, this is the only alkene we can make from this one. There's only one. When we do hot alkene oxidation, we're going to cut this in half, and we're going to get a 3-carbon compound and a 1-carbon compound. So ponder how you would make this. It's not 1 step, but it's only 2 steps, right? Here's an alkane. We only talked about 1 reaction you can do with an alkane. So you're going to do that reaction, and then you're going to do a second reaction to make this alkene. So we're going to make the alkene. Then we're going to rip it apart using our good buddy, alkene oxidation. Now we know we're going to have to sew this back together again. Right? So we know we have a 3-carbon compound and a 1-carbon compound. So over here somewhere, we're going to have our 3-carbon compound and our 1-carbon compound. And what is the reaction that will sew these back together? It must be Grignard, right? Now we can do this in different ways, but remember that Grignard usually involves something like haloalkane that we make our Grignard reagent, and something like C double bond O. So think about what makes sense here, right? But one possibility is something like this and this. So think about what pieces you make here and how you can convert this piece into that piece, and how might you convert this piece into this piece. That's a little harder, right? Because here you're going to have a functional group here in the middle, and you want to somehow transfer that functional group to the end, right? So think about how you might do that. That's a couple of sort of steps to go from here to here. Once you have these pieces and you do Grignard, you won't make this, but you'll make something that is a 4-carbon compound, and then you can use a couple of steps to get rid of those functional groups. Remember, in terms of getting rid of functional groups, one way we can do that is Grignard can help us get rid of functional groups, especially haloalkanes. You can also eliminate things using E1 or E2 if the functional groups are secondary or tertiary. So think about how you might sort of do that. But here's sort of the mental process for this, and now it's just a matter of figuring out what are the steps to go between, right? But if we have something that looks like this and we want to end up with this, we need to tear it apart, which means alkene oxidation, which means we need to make an alkene. And if we're sewing it back together, we're sewing it back together with Grignard, which means somewhere we're going to have something like this. So this is a little bit of retrosynthesis and a little bit of forward synthesis. And actually, in this case, it's helpful if you can find a way to make them meet in the middle. So maybe you can figure out what is like the last step or the last couple of steps, what are the first couple of steps, and how do we take this from that. So try that out. Again, don't work alone. Get your buddies to help you. I'm available for office hours. Good luck.